Welcome once again. So in our previous class, we started with matrices. So under matrices, we learned about equality of matrices. We learned about addition and subtraction of matrices. We also learned about how to multiply a scalar matrix. Then at the same time, we ended our previous section with multiplication of matrices. So today, we are going to continue and we'll be looking at determinant of a matrix. Then we move on to adjoint of a matrix with some examples. Then we move on to transpose of a matrix. Then we finish today's class with inverse of a matrix. So I would like you to subscribe to the channel if you have not, so that any new video that will be posted, you get notified, then enjoy the class as well. Alright, so without wasting my time, begin with today's class and we will start with determinant of a matrix. So say the determinant of a matrix A is denoted by that A or matrix A. So the determinant is denoted by what? That A or A. So for example, if M, which is a 2 by 2 matrix, equals to A, B, C, and D, then we say that what? Determinant M or that M will be equal to the product of the leading diagonal. Product of the leading diagonal minus product of the other diagonal. So the leading diagonal will be what? A and D. They are the leading diagonal minus the other diagonal. And the other diagonal, we are going to get what? The other diagonal is E and B, or B and C. So if you look at here, we had what? That M equals to AD minus BC. That's for 2 by 2 matrix. But for the 3 by 3 matrix, there will be a little changes. So let's look at how it is done. So if Y equals to matrix, or if matrix Y equals to A, B, C on the first row, and on the second row we have D, E, F, and on the third row we have G, H, and J. Then we say that what? Determinant Y can be found when we take A, or when we look at the first row, we take the first component, and the first component on row 1 is A. So we take A and multiply it with E, F, and H, G. Why do we multiply it with E, F, and H, G? We assume that once we've taken an element, or once we've taken a component of column 1, which is A, D, and J, and row 1, which is A, B, C, we assume that the column and the row, they do not exist once we've taken a member there. Because if you take this member out, it is no more what? A 3 by 3 matrix. Alright. So once we've taken it, we assume that what? We assume that row 1 and column 1 do not exist. So therefore, the element left for us to use is what? They are E, F, H, and J. Then we move on to the next one, and the next element on the first row is B. So when we take B and we assume that the entire row is normal, and the entire column is normal, we are going to get what? B multiplying D, F, J, and J. D multiplying D, F, J, and J. So that's what we have here. Then when we take C out, we also assume that what? We also assume that row 1 is not there, and column 3 too is what? is out. So we are going to get what? C multiplying D, G, E, and H. Alright. So with this, we go back to multiplying the leading diagonals. Then we subtract from the product of the other diagonal. So we are going to get EF HJ minus B multiplying DF J and J plus C multiplying bracket D E J H. Alright. So matrix or determinant Y will be equal to, when you multiply the leading diagonals, we are going to get EJ minus FH bracket close minus the next term, which is EB bracket D times J. So you are going to get DJ minus JF minus JF plus C, which will give us DH minus what? AG. Alright. So if you've paid much attention, you could see that there is some addition here. There are some operational signs being inserted in the equation. So you can see that we have minus here, then we have addition here. Why? It is because of what? It is because of, or it is a cofactor sign. So with 3 by 3 matrix, the cofactor sign says that what? With the first row, of a 3 by 3 matrix, we should have what? Plus, minus, plus. And the second row says that, or on the second row, we have minus, plus, minus. And on the third row, we have another plus, minus, plus. So if you look at this one, that's because we are using only the first row. And since we are using only the first row, we are going to pick plus, minus, plus. We are going to take this one. Plus, minus, plus. Thank you very much. So without wasting much time, let's move on with our first example. So the first example says we should find the determinant of n. So example 1. Example 1. N equals to n equals to 3, 1, 4, 2. N equals to 3, 1, 4, 2. And we have to find that n. So you say that n will be equal to, the 10 will be equal to, our first leading diagonal is what? 3 by 2. So I'm going to get 3 times 2 minus the other product, minus the product of the other leading diagonal. Then the product of the other leading diagonal is 4 times 1. So that n is going to give us 6 minus 4. So therefore that n Let n equals to 2. Good. So that n equals to 2. With our first example, that n equals to 2. Let's move on to the second one. So number 2. With example 2, we said that we should solve the equation. So this one, the determinant has been given, and the determinant is what? 7 minus 2, 3x5 equals to 37. So we are finding the value for x. We are finding the value for x. So we have 7 minus 2, 7 minus 2, 3x plus 5 equals to 37. So let's let's apply what the root of determinant says. We multiply the leading diagonals, then we subtract the product of the other diagonal. So we are going to get bracket of 7 times 5. So 7 times 5 is 35 minus negative 2 times 3x. We are going to get negative 6x. Yes, so we put the negative 6x in bracket so that we don't confuse ourselves with the formula. Then we equate it to the 37. Equate it to the 37. So we are going to get 35 minus or plus 6, because negative will give you positive, plus 6x equals plus 6x bracket close equals to 37. So from here we group like terms. So we are going to get 6x equal to 37 minus 35, because 35 over here is positive. So when it crosses the equal to sign, it becomes negative. So therefore, 6x will give us, we are going to get 6x equals to 2. So x will equal to 1 over 3. So 1 over 3 is the value for x. Alright, let's move to the next example. In the next example, we have matrix B equals to 2, 3, 4, 2, 2, 6, 2, 5, 2, 4. So number 3, which is matrix B, equals to 3, 4, 2, 6, 2, 6, 2. That's for the second row. Then the last row, we have 5, 2, 4, 5, 2, 4. So We ask to find the determinant. So that B will be equal to, so let's pick the first component, which is 3. So we take our 3. Then we assume that once we've taken the 3, row 1 exists no more. Then column 1 also does what? Exists no more. So the element left for us to use are what? 6, 2, 2, 4. Then our cofactor sign says what? Our cofactor sign says plus, minus, plus, minus, plus, minus. Then plus, minus, plus, minus, plus. So with this one, we are dealing with the row 1. And the row 1 says that what? Plus, minus, plus. So we are using this. That's why the 3 is positive. So the next term is what's negative. So minus. So we take the next element, and the next element is 4. So minus 4. We assume that once we've taken 4, row 1 does not exist anymore, and column 2 also does not exist anymore. So the elements left for us to use are 2, 5, 2, 4. Those are the elements left for us to use. So move on to the next one. The next one says, move on to the next one, and it says that what? It says that class 2. So we also assume that what? Once the 2 has been taken, row 1 is no more, and column 3 is no more. So we are left with the elements of 2, 5, 2, 5, 6, 2. Alright. 2, 5, 6, 2. So let's check and see if we have all the values. So you can see that we have 6, 2 here. 6, 2 as the beginning for as the first column for the first column for the first matrix, and it is seen as the last one. Do you get that? So you see, after you are done with this, you compare and see that you can see all the elements. So we have 6, 2, 6, 2, 6, 2, 2, 4, 2, 4, 2, 5, 2, 5. Do you get that? We have all the elements. Then we proceed. So we are going to get, or that P is going to be, that B will be equal to 3 bracket leading diagonals. So 4 times 6 will give us 24 minus 2 to 4. Then close the bracket. Minus 6 and 4. Our leading diagonals, 4 times 2, 8. Minus the product of other diagonal. 5 times 2 will give us 10. Plus 2. So the leading diagonal here is what? 2 times 2, which is 4. minus 8530. We see that the first row, the element on the first row or the components on the first row, over here they are acting as scalars. They are acting as what? Scalars, because you can see the 3 here acting as a scalar, the 4 here acting as a scalar, then the 2 here also acting as a scalar. So we say that what? That B will be equal to 3 brackets 24 minus 4 is 20 minus 4 brackets 8 minus 10 will give us negative 2 plus 2 bracket 4 minus 30 will give us what? Negative 26. Alright, so we are going to get that B will be equal to 3 times 20 will give you 60 minus 50 minus or better still, negative 4 times negative 2 will give us positive 8, so plus 8. Then 2 times 26. 2 times 26 will give us 52, so minus 52. Minus 52. U will be equal to 8 because 60 plus 8 will give us 68 minus 52 and delta B or determinant B will be equal to determinant B will be equal to 16 will be equal to 16. Alright. So please kindly subscribe to the channel and then leave your questions in the comments box. So this will be your first trial question. Then move on to adjoint of matrix. So we say that adjoint of matrix, adjoint. Adjoints. We say that what A is an M times N matrix. Then the adjoint of A is the transpose of the cofactor of A. So what you are simply saying is that what if A or matrix A, which has the components of A, B, C, and D, then the adjoint of A will be equal to what? B, negative C, and A. So with adjoint of matrix, we interchange the leading diagonals. Yes, so if matrix A equals to A, B, C, and D, we say that what adjoint of matrix A will be equal to what? D minus B minus C and A. So with adjoint, we interchange the leading diagonals. The position of the leading diagonals, we interchange them. We interchange the position of the leading diagonal. That's why we had D to be in the position of what? A, and A to be in the position of D. Then we negate the other diagonals. The other diagonal, we negate them. So let's see, we have a short phrase here explaining it better. It says that is interchanging the leading diagonal and negate the other diagonal. As we've done it here. So we've interchanged the leading diagonals, which is A and D. Right now we have the adjoint of A has become what? D and A. Then we've negated the other diagonal, which is negative B and what? Negative C. Alright. So example 1, if you find the adjoint of M or the adjoint of matrix M, which is equal to 2 to 3 negative 4. So M, adjoint M or M equals to 2 to 3 negative 4. So we are going to get what? Adjoint A. Adjoint A should be equal to, I'm going to get adjoint A to be equal to what? So the leading diagonals have 2 and negative 4. We are going to, so we interchange their positions. We are going to get negative 4 and 2. Then the next thing is we negate the other diagonal. So we are going to get negative 2 and negative 3. As simple as that. If you have any question, you drop it into the comment section. So now we are done with adjoint. We are moving on to transpose of a matrix. So the transpose of a matrix is obtained by changing its rows into columns and its columns into row. As simple as that, as the phrase is explaining itself. So to transpose a matrix, it is obtained by what? Changing its rows into columns and its columns into rows. That's that. So to transpose a matrix, it's written as what? So transpose A is written as A with a superscript of T or A with an apostrophe. Any of these represent what? A transpose of a matrix. So to transpose a matrix, write the first row as the first column. So to transpose a matrix, write the first row as the first column, the second row as the second column, and so on. As simple as that. So it says that what? We write the first row, write the first row as the first column, the second row as the second column, and so on. So if it is 2 by 2 matrix that you are treating, the first row is the first column, the second row is the second column, and that's that. If it is 3 by 3, the first row is the first column, the second row is the second column, and the third row is what? The third column. Alright, so let's see some examples here. So assuming that we have, so transpose of a matrix. of a matrix. We will be just changing the rows to columns. Changing of what? Rows to columns. Changing of rows to columns. So let's take note. Then I'm reminding you that subscribe to the channel, and the channel is Board Engineering, so that anytime we upload new videos or new lessons, you will be chanced to go through to better your understanding in your academic field. All right. So assuming that we have matrix A, which equals to A, B, E. We have B, E, and F. A or M, N, and P. These are the elements of matrix A, and we've been asked to transpose it. So transpose A. Then I bring my superscript T, showing that I'm transposing it. I will get what? So say that we change what? The first row into the first column, the second row into the second column, and the third row into the third column. So we are going to get A, B, C, because A, B, C is what? Row 1. So row 1 now, after transposing, it becomes our first column. Then column 2, we are going to get what? D, E, and F. So D and F becomes our second columns, and the last one, we have row 3, which is M and P. Row 3 becomes our third column, so we are going to get M, N, and P, which becomes our third column. So now, when you do this, we have been able to what? Transpose matrix A. Let's move to the next one. The next one, and our final topic for this section, will be inverse of a matrix. Inverse of a matrix. Don't forget that whatever it is that we began from determinant of matrix, adjoint of matrix, transpose of matrix, we are yet to apply it, or we are going to apply it in the dealing of what? Inverse of a matrix. So we say that if A is a matrix, then the inverse of A is denoted by A exponent -1. A exponent -1, and given by A exponent -1 equals to 1 over det A. 1 over det A times the adjoint times the what? Adjoint. Alright. So we say that if the matrix A has 0 determinant, then A is said to have no inverse, or A is said to have no multiplicative inverse of A, or A is a single matrix. Yes, because let's look at the formula. The formula says that what? 1 over det A. 1 over det A times adjoint. So it is if matrix A. So matrix A, probably it is through matrix A that we are going to get what? The determinant. And since matrix A has 0 determinant, and in mathematics, any number over 0 is what? 0. we get that any number over 0 is 0, and 0 times any number is 0. So we will not get inverse. So they say that the inverse, there will be no what? No inverse. Or if it's said to have no multiplicative inverse. Alright. So let's move on. Let's move on. So steps to obtain inverse of a matrix. So the steps to obtain inverse of a matrix. So we have 4 steps. So the first one says that what? We should calculate the determinant. So when the matrix is given, or when the matrix is given, we first calculate the determinant. We find the adjoint or cofactor. So we find the adjoint. Adjoint in one way or the other is the same as what? Cofactor. But for 2 by 2 matrices, we use what? Adjoint. But for 3 by 3 matrices, we use what? Cofactor. Then the third one, we transpose the cofactor for 3 by 3 matrices. As it has been stated here, we do what? We transpose the 3 by 3 matrix. Then the last point, we do what? We substitute the values. We substitute the values in the inverse formula. And that is what? Inverse equals to 1 over that A times the adjoint, or the transpose of the cofactor. Yes, let's say that the transpose of the cofactor. So the first question, we have the first question. And this 2 by 2 matrix, so you should find the inverse of A. So inverse of a matrix. With this, whatever that we started today, we are going to apply everything. We are going to what? Apply everything from the scratch to where we are now. So inverse of a matrix. So example 1. Example 1. We have what? Matrix A to be equal to, we have matrix A to be equal to 2 to 3 negative 4. 2, the elements are 2, 2 on the first row, then 3 negative 4 on the second row. Alright. So let's look at the steps. The step says that what? First we should find the determinant. So first step 1. Step 1. We find the depth. So depth A will be equal to what? We multiply the leading diagonals and subtract it from the other, or the products of the other diagonal. So we are going to get 2 times negative 4. So we are going to get negative 8. So this is the leading diagonal. Negative 8. The leading diagonal. Then we subtract it from what? The other diagonal. And the other diagonal is what? 3 multiplying 2. So we are going to get 6. So we are going to get that A to be equals to negative 8 minus 6. We are going to get negative 14. Negative 14. Are we following? Are we following? Are we following? Alright. All right. Then we have from here, the next step says that what we find the adjoint of the cofactor, the adjoint. So adjoint, step two, step two, step two, step two, adjoint A, adjoint A will be equal to what? Let's look at our values or our elements here. We have 2, 2, 3, 4. And the rule for adjoint of matrix says that what we should interchange the leading diagonal, and the leading diagonals are 2 and 4. So we change their positions. So we are going to get negative 4 and 2. Then we should negate the other diagonal. So the other diagonal, we are going to get negative 2, negative 3. Then since this is a 2 by 2 matrix, we are not going to find the cofactor nor the transpose. So we just insert it into the inverse formula. So step 3, step 3, step 3. We do what? We substitute, and the formula is A inverse equals to A inverse equals to 1 over that A times what? Adjoint A times adjoint of A. Good. Do it this way. Alright. So A inverse or inverse of A will be equal to 1 over that A was what? That A was negative 14 minus or negative over negative 14 times the adjoint. Then the adjoint was what? Negative 4, negative 2, negative 4, negative 2, negative 3, 2. Then we are done with the first question. We are done. We are done with the first question. All right. So let's move on to the next question. Let's move on to the next, which is question 2. Question 2. Question number 2. Matrix P equals to, let's look at the elements 5, 2, 5, 3 on the first row, 2, 5, 3, 2, 5, 3 on the first row, then 3, 1, 2, 3, 1, 2 on the second row, and 1, 2, 1 on the third row, 1, 2, 1 on the third row. So with this, as the step says, so we start, let's see, or let's look at the steps. Step one says you should calculate the determinant. So first, we calculate for step one is what? We look for that A. So step one. So that's B, because the matrix is what? B. So that B will be equal to, so this is a 3 by 3 matrix. So first, we take the first component from the first row. So once we take the first component, which is 2, we assume that what? Row 1 and column 1, they do not exist. So we take the remaining element, and the remaining elements are 1, 2, 2, and 1. We multiply it by what? 1, 2, 2, and 1. Then don't forget that the cofactor sign says that what? Plus, minus, plus, minus, plus, minus. Then what? Plus, minus, plus. And with this one, we are dealing with the first row. So we are taking this. All right. So we move on to the next one. And the next element on row 1 is what? 5. Then according to the cofactor sign, what sign are we using? We are using negative. So minus 5 minus 5. What elements are we picking? We've taken 5. And we assume that what? We assume that so once we've taken element 5 or the second component from first row, we assume that row 1 does not exist anymore, and what column 2 also does not exist anymore. So we are left with the components of 3, 2, 1, 1. We multiply 5 by what? We multiply 5 by 3. We multiply 5 by 3, 2, 1, 1. 3, 2, 1, 1. Then the next sign is plus. So, so we take 3 and assume that once we take 3, row 1 does not exist, column 3 also does not exist. So we are going to get 3 multiplied by 3, 1, 1, 2. So that B. That B will be equal to, that B will be equal to 2 bracket. So we multiply leading minus other. So 1 minus 4, because 2 times 2 give you 4. Then 5 bracket 3, 1, 3. 2 times 1, so minus 2, bracket close, plus 3, bracket. 3 times 2 give us what? 6. Minus 1 times 1 give us 1. Okay. So we see that what? That B equals to 2 bracket negative 3 minus 5 bracket 1, because 3 minus 2 is 1, plus 3 bracket 6 minus 1 is 5, 5 bracket close. Let me do the addition sign here. So plus. Alright. So that B will give us 2 times negative 3 will give us negative 6. Negative 6 minus 5 times 1 give us 5, plus 3 times 5 is 15, plus 15. So that B will be equal to 4. So the determinant is 4. Then the next one is find the adjoint or cofactor. Find the adjoint or cofactor. So step 2. So step 2. We are going to find the cofactor. So cofactor. Because this is a 3 by 3 matrix. Assuming it was to be 2 by 2, we could have find what? The adjoint. So cofactor. With cofactor, the cofactor, we are following the same procedure for what? The same procedure for how we solved the determinant. But this time around, we will not have any scalar. This time around, we will not have what? Any scalar. So let's see how it is done. So let's say that cofactor should be equal to what? C. So let's say cofactor should be equal to C. We are going to get C equals to the first one we are going to take is, so let's take the first element. Let's take the first element. So once we take the first element, we assume that what? The first row is off and the first column is also what? Off. So we are left with the element of 1, 2, 2, 1. So 1, 2, 2, 1. The first element. For the first element. And don't forget that the cofactor sign says what? For the first row, we have what? Plus minus plus. Alright. So let's take the second element and assume that the first row does not exist and the second column does not also what exist. So we are left with the element of 3, 2, 1, 3. So minus 3, 2, 1, 1. Bracket close. Plus, let's take the last one, or better still, let's repeat this. Let's repeat this without the scalar. Let's repeat this without the scalar. So we are going to get 3112 plus 31 31 1 2 bracket close. Then we move on to the second one, or we come to the second row. So the second row, we are going to use what? We are going to use this. Or we are going to use this. So let's assume that we are taking the first element, and the first element is 3. So row 1 or column 1 does not exist. We assume that it does not exist. And row 2 also does not do what? Does not exist. So the element left for us to use is what? 5, 3, 2, 1. So we are going to get 5, 3, 5, 3, 2, 1. 5, 3, 2, 1. Then we close it. This here is negative because the cofactor sign says that what on the second row, the first element should be, or the first component should be negative. The second one should be positive, and the third one should be what? Negative. So we have our negative here. Then, once we are done, we move on to the next element, which is 1. So we assume that what? Row 2 does not exist, column 2 does not exist. So we are left with the element of 2, 3, 1, 1. So plus 2, 3, 1, 1. Then minus, because minus is the next one. So once we are done with this, we move on to the next element, and the next element is 2. We assume that column 3 does not exist, row 2 does not exist. We are going to get the elements of what? 2, 5, 1, 2. So elements of 2, 5, oh sorry, 2, 5, 1, 2. So let's extend our bracket. Let's extend our brackets. We close it, then we extend it here. Then move on to the next one. 2, 5, yes. Move on to the next one, or the next row, which is the last row. So we take 1, or yes, 1. Then assume that row 3 does not exist, column 1 does not exist. So we're left with the components of 5, 3, 1, 2. And on the third row, the cofactor sign says that what? The first component is positive, the second is negative, and the third is what? Positive. we are going to get positive 5, 3, 1, 2. We are going to get 5, 3, 1, 2 minus what is next? The next one is 2. We assume that column 2 does not exist, row 3 does not exist. So we left with 2, 3, 3, 2. So 2, 3, 3, 2. Then close the bracket nicely. Then the last one is plus. So we are going to get, or we assume that column 3 does not exist, row 3 does not exist. So we are going to get 2, 5, 3, 1. So we have 2, 5, 3, 1. Good. And once we have this, we are almost done. We are going to say that C will be equal to, so we cross multiply the leading, or we multiply the leading diagonals, then subtract the products of the other diagonals, like we've been doing for the determinant. So we are going to get this. So 2 times 1 times 1 will be what? So 1 times 1. 1 times 1 will be 1 minus 2 times 2 will be 4. And close your brackets nicely. Minus 3 times 1 will give us 3. 3 minus 2. 3 minus 2. We close our brackets nicely. Then the last one is plus 6. 3 to 6 minus 1. Because 1 times 1 is 1. Close our brackets nicely. So the next one will be, or on the second column, we're going to have negative brackets. 5 times 1 will give us 5. 5. 2 3 minus 6. Bracket close. Then plus 2 times 1 give us 2. Plus 2 minus 3. Because 3 times 1 give you 3. Plus, minus 2 minus 2 to 4. Minus 4. 2 times 2 give you 4. Minus 5. Because 1 times 5 is 5. Then the last one, or the last column, we have we have what? 5 times 2 gives you 10. Minus 1, 3. Brackets close. Plus. Sorry, minus that of minus to 4. Then 3 times 3. 3 times 3. 3 times 3 minus 9. Then plus 2, 1, 2. Minus 15, 3, 5, 15. Good. Oh, once we are done with this, we do as addition and subtraction. Note that this is a 3 by 3 matrix. So we are not going to sum up all these. We sum up or we sum them individually so that we can get back our 3 by 3 matrix. So C, which is cofactor, will be equal to what? Negative 1 minus 4 will give us negative 3. Negative 3. Then negative 3 minus 2 will give us 1. So 1 times negative 1 will give us negative 1. Then 6 minus 1 will give us 5. Positive 5, of course. Then 5 minus 6 will give us negative 1. Negative 1 times 1 times negative 1 will give us 1. Will give us 1. Then 2 minus 3 will give us negative 1. Then 4 minus 5 will give us negative 1 times negative 1 will give us 1. Then 10 minus 3 will give us 7. Then 4 minus 9 will give us negative 5 times negative 1. So we're going to get 5. Then 2 minus 15 will give us what? Negative 13. Good. So now that we have the cofactor of B, yes, the cofactor of matrix B, we can transpose matrix B. So we see that what? Step 3. Step 3. B transpose. B transpose will be equal to. So let's take the first row from the cofactor. The first row is what? This. We are going to get negative 3, negative 1, then 5. Because we say that what? Transpose, the first column becomes what? The first row becomes the first column, and the second row becomes the second column, and the third row becomes what? The third column. So that's that. Then the second column is what? This. We are going to get 1, negative 1, negative 1, and what? 1. That's for the second. Then with the third row, we have what? This. The third row, we have 7, 5, 13, which is negative. So this is our transpose. So once we are done with the transpose, the next step says that what? We substitute the values into the inverse formula. We substitute the values into the index formula. So step 4. So if you have any comments, you leave it into the comment box. Your comment, your answers, your suggestions, they will be attended to the moment you drop them. All right. So the inverse formula will be what? This time around, the matrix is B. You're going to get B inverse will be equal to 1 over that B times the adjoint of B, which is the same as the cofactor or the what? The transpose. We are going to get B inverse equals to 1 over, let's look at this. Determinant B was what? 4. So 1 over 4 times what? Adjoint of B. So after the transpose, we had what? Negative 3, 1, 7, negative 1, negative 1, 5. And the last one was what? 5, 1, negative 13. Such a nice, lovely, and enjoyable question. So you see, we've combined all that we did today. We've combined all before we arrived at our final destination, which is what? How to find inverse of a matrix. So first, you find your what? First, you find your determinant. So with this question, our determinant was 4. Then we proceed to finding our cofactor. And our cofactor, we had negative 3, negative 1, 5 on the first row. On the second row, we had 1, negative 1, 1. And on the third row, we had what? 5. We had 7, 5, and negative 13. So from there, which is the step 3, we transpose. Since the matrix is a 3 by 3 matrix, we transpose. And we say that during transposition, we change the first column of the cofactor. So the first column, we change the first row of the cofactor. So the first row was what? Negative 1, negative 3, negative 1, 5. We change them or we convert them to become what? First row. So if you look at this, our first row here after transposition is what? Negative 3, negative 1, negative 7. And our first column is what? -3, -1, 5, which was first the what? Which was at the beginning the first row. And the second column is what? 1, -1, which was the second row for the cofactor. Then 7, 5, -13, which was the second, or which was the third row for the cofactor. Now is what? The third column for after transposition. So after then we move on to the step 4. And the step 4 is we substitute the values back into the inverse formula. So after substituting, we had 1/4 multiplying the matrix of 3, -3, 1, 7, -1, -1, 5, 5, 1, -13. So this will be the end of today's session. Thank you for your time. Thank you for your attention. Note, don't forget to subscribe to board engineering, because with board engineering, all your engineering mathematical questions, you solve them within a second. The goal is what? A+. Don't forget to subscribe to board engineering for more lessons. Thank you very much. See you next time. Bye.